We're going to be talking about arc length today. Arc length has to do with the area, but not the area of the circle, the length that goes around the circle. Now, we've already got a word for the length around of a circle, and it is circumference. The circumference is that distance around the circle. And it's a distance, like if you were going to try to run around the circle, how long would it take you to go around the circle? Now, we talk about circumference a lot in geometry. When I'm in geometry, I normally talk about track a little bit. This is a very bad track. And as Amarius will tell you, if you run a 200-meter race, that means they need to go about halfway around, right? And the 200 will finish somewhere like right here. This is the 100, the other straightaway. But the starting position of the 200 will be kind of strange, right?
It's staggered.
It is staggered, right? The starting positions for all the different racers, one guy gets, or maybe girl, gets to start all the way at the front, and another person gets to start all the way in the back. How come A gets such a head start over F? Exactly. A mathematician has calculated that, I know that A looks like they get a head start, but it takes a long time to run around the outside of the circle, whereas the inside of the circle is a shorter distance. And so the mathematician has perfectly spread out these lanes so that everybody has to run 200 meters total. If we all started like this, well, then F gets to run a little shortcut, and A would have to run all the way around. It wouldn't be very fair. And this is kind of what we're talking about with our lengths of our arcs, because we're not really talking about circumference. Circumference would be the whole circle. I know the tracks aren't circles either. So let's start with circumference, then we'll build it up. The area, I keep saying area, it's not area at all. The formula for circumference is 2 pi r. Something that you've learned before. It can also be called pi d, because 2 r's, if you have 2 radiuses, that makes a diameter. So sometimes it's called pi diameter. And that circumference is all the way around the whole thing. For this right here, we would have a circumference of 2 pi times 5. We would have a circumference of 10 pi. But what if I don't want that whole circumference? What if I want just a fraction of that circumference? What if I want just a portion? And so that's what an arc length of a circle is. It is a portion or fraction of the circumference. And so here we are. We have a circle, and we're not looking for the full circumference. Let's try to find just this circumference here, which is not really the whole circumference. It's just a part of that circumference. It's just a piece of that circumference. Now, if we were going to talk about this, it's really easy to talk about this using pi or pizza, but pi is confusing because we already have pi's when it comes to these circles. So let's talk about this when it comes to pizza. If I color this yellow, and if I put some pepperonis on the pizza, when we're talking about the arc length, what are we talking about in terms of pizza? Nice, genius. Maybe just hungry. The crust, right? Arc length is trying to calculate the crust, just that outer edge. What is the length of that crust? Now, back in geometry, we did have a formula for this, although you don't do it very much, and I'll be honest, you most likely forgot about this, okay? The formula would be r theta with a pi divided by 180. And this was a formula that we used back in geometry. And again, you probably forgot about it, or maybe it was just a little unit that they left off or something, but this is a formula that is a thing in geometry. Before we get there, we need something to call arc length. Here's honestly one of the hardest parts of the whole class. What letter are we going to call arc length? We can't really use A. Why can we not use A? A is area, right? And so I know that we're doing arc length, but we can't really use A. If we can't use A for arc, maybe we could use L for length. And there's a problem with L's. L's look like ones, and so we don't really like to use L's either. And so sometimes you might see an L. Maybe it would be like a fancy cursive L so that it really does not look like a 1. But again, we don't really like these L's that much. And so we need a letter. It's arc length. We can't really use A, we can't really use L, and they have chosen S. Why is it S? I don't know. Maybe because we're talking about sectors. They've chosen S because of sectors, but here's the only thing that matters. We're using S, who cares? We move on. Now, back in geometry, let's say we were gonna do this question. It says that the radius is 5. So let's figure this out. It would be pi over 180. What's the radius? 5. And what is the angle for this question? Right. It shows us that it is a right angle, and that means it is 90. And we would just type this all in the calculator, and we would get an answer, and we would be done. So let's do it. That's a great question. Let's put pi in the calculator. Does everybody know where to find pi in the calculator? It is by the clear button. Now I'm hoping that you get a number less than 10. Let's do 1 decimal place. Does anybody have an answer? Love it. 7.9. What if we want to be teacher's pet and we want to put a little bit of a unit on this? It would be 7.9. Isn't there units on this? Yeah, centimeters. Took the T's off the pizza. Now, here is the most important part of today. If this was back in geometry and we already learned how to do it, then what are we doing? What's the point of this? Why are we learning this in TRIG? Here's what we're learning in TRIG. 90 is 90 degrees. Now that we are in TRIG, we have another version of 90 degrees. Now that we are in TRIG, we know that the radians exist. Now here's what's going to happen, okay? Should it change the length of the pizza? It should not. But if we get rid of a 90 and we replace it with a pi divided by 2, it's definitely going to change, right? So here's what we're going to learn today. There is a degree version of the formula and there is a radian version of the formula. But here's the good news. Here's why this is so easy, okay? I'm going to go back and look at this 90 here. And I'm going to move my box over to this pi over 180 part. What does pi over 180 do? We've learned this in class. Pi over 180 is your conversion. Pi over 180 converts degrees into radians. So, here's what I'm saying. This formula is radius times your degrees. And what this part does is it takes your 90 and it converts that 90 into radians, right? This is something we did before. On your calculator, 90 divided by 180 is 1/2. And so we have 1/2 pi. Okay, here's what's going on. Using radians, this formula is much easier. If we have S equals pi over 180 r theta, and all that this does is convert u to radians, what if we start the question in radians? S equals r theta. Do we need the conversion part? No, because we're already radians. Do we need to convert to radians if we start in radians? No. So here's what we're learning today. This formula is a bit ugly, it is messy, and it works for degrees. And really, we don't really like it that much. It's okay, it doesn't feel great when we do it. This formula, now this thing rocks. It is literally just two numbers multiplied together. That's it. This formula is the best. It is short, it is clean, but here's the thing. This formula is radians only. Okay, here's our objective for the day. You need to use these two formulas. Really, it's the same formula. One of them is degrees and one of them is radians. And we love the radians one. It is so easy. It is literally just multiply two things together and you're done. Excellent. But maybe we'll see a question in degree form where we run into a little bit of an issue, and then we're gonna have to go back and use this old formula. All right, let's do it. Down here, determine the measure of the intercepted arc. Well, we don't even have any information for this question, so let's make one up. Somebody shout a number out. That can be our radius. 89. The first one that I heard, I don't know.
Was what?
88.
Yeah. No.
88 was the first one I heard. Now, okay, kind of weird. That's a big number, but so be it. You get to choose. Number 2, let's choose an angle, but let's choose radians. Any radians that you want in the whole world. It really just needs to be a fraction. We already did pi over half, so let's do pi over 4. Okay? Now we know that pi over 4 looks maybe something like this. Pi over 4. Now our formula is S equals R theta. That's it. We do not need the pi over 180 because that pi over 180 is our conversion, but we don't need to convert. So easy, very, very easy. S equals, what is the radius? 88. What is the theta? What is the angle? Pi over 4. Now those are supposed to be multiplied together. In your calculator, 88. You can do alpha y equals to make it a multiplication. What did I do with my calculator? Stuck it around. Okay. 88 times alpha y equals inner pi over 4. Now I got a number less than 75. Anybody get that? All right, S equals 69.1. There we go. Great question. You guys, geniuses. How did you come up with that off the top of your head? I'm not so sure. Okay, we did it. We created a random question with the answer 69. It's the best thing, best possible case scenario. But before you flip to the back, stay with me really quick. Okay? This question says, give your answer in terms of pi. This is probably going to be the thing that you guys are going to struggle with more than anything else. So far, what we've learned is that the formula is so easy. You just literally multiply two things together and you're done. Okay? There are two versions of every answer. Okay? This is the decimal answer. This includes pi. Pi has been melted into the answer and it has given us a decimal. Sometimes it will ask you to give your answer in terms of pi, which means don't melt the pi into the answer. It means keep the pi separate. And so if it says answer in terms of pi, what that means is don't type pi. Okay? That means type everything else up here. We could type 88 times. If we're not going to put the pi in the calculator, what do we put up on the top? A 1 is fine. 88 times 1/4. That tells me the number 22. And then pi. I'm telling you, students always forget to put that pi there. Now, these are the same thing. These are the same thing. This one, we baked the pi. We multiplied it in there. This one, we just saved it for later, right? We just got it out the fridge. We haven't baked it yet. We're just keeping them separate, two separate desserts. Everybody's good. Okay, at this point, we've talked about everything for the whole thing. We're gonna do 3 quick questions, and I say quick, we're going fast. A circle has a radius of 3. Find the length of the arc measured by 2 pi-thirds. We need to use our formula. Is it the simple formula for radians or the complicated one for degrees? Simple radians. S equals r theta. S equals 3 times 2 pi-thirds. And it says give your answer rounded. Are we baking the pi into the number? Yes. 3 times alpha y equals inner 2 pi over 3 inner. I got a number less than 10. Somebody shout it out. 6.3. Genius. And that's it. The question's over. You just take 2 numbers, multiply them, move on. We're moving on. We're going fast. These questions are easy. A circle has a diameter of 36.4. Find the length of the arc intercepted by the angle having 11 pi-7 radians. Give your answer as a decimal. Easy formula or complicated formula? Easy. What is the radius? Good catch, right? We have taken geometry already. This is not very hard. 36 divided by 2 gives us 18. Multiply that by our angle, 11 pi-7. It says give your answer as a decimal. Are we baking in the pi? Are we typing it in? Yes, do it. 18.2 times alpha y equal enter 11 pi over 7. I got a number less than 100. What'd you get? 89.8. Done. Easy. Literally just type them both in and move on. Last question. A circle has a radius of 2.75. Find the length of the arc intercepted by the angle having a measure of 144 degrees. Okay. Simple formula or the more complicated one? Right. Remember, there's only one difference. We just put a pi over 180, and what does that do? It converts your degrees into radians. So all that this does is it just takes your degrees and turns it into a pi. It says give your answer as a decimal, so we're gonna be typing everything in. S equals 2.75 times 144 times pi over 180. 2.75 times 144 times pi over 1 equals 80. Pi over 180. I got a number less than 10. 6.9. All right, what if I wanted to ask you a little bonus question? Can you give me the answer for example 4 in terms of pi? Can you give me the answer for number 4 in terms of pi? Well, this should be very easy. We're gonna type the same exact thing in, except for no pi. We can even press the up arrow on our calculator and just copy the last thing we typed. Go back to the pi, replace it with the 1, press enter. I got 2.2 pi. Okay, you don't have much of an excuse for struggling on this stuff. You literally multiply two numbers together. If it says decimals, type the pi. If it says do not give me a decimal, then leave the pi out. That's probably the hardest thing, is when you leave the pi out, how you type it in, and then make sure, if you're doing it in terms of pi, it should slap a pi on the end of it. That's it. Arc lengths, easy. We're done.